Let's continue to look at line 3 and line 4. Line 3 has vector equation going through the fixed point 1, minus 1, 4, and the direction vector of line 3 is 2, minus 1, 3. And line 4 going through a fixed point 1, 0, 3 with direction vector negative 1, 1, and negative 2. Do you think that line 3 and line 4 parallel, intersecting, coincident, or skew? So which one do we check first? Usually we start with checking whether line 3 and line 4 are parallel or not. So if we look at the direction vector of line 3 and the direction vector of line 4, do you think we can rewrite 2 minus 1, 3 as k times of negative 1, 1, and negative 2? If we look at the y component, if you say k is negative 1, does this apply to x coordinate or is it valid? So if we check the x coordinate 2, if k is negative 1, 2 can never equals to negative 1 times negative 1. So k equals to negative 1 is not true for the x value. So therefore we can never find a k value where the direction vector of line 3 is always equals to k times of the direction vector of line 4. So because of that, line 3 is not parallel to line 4. So if line 3 and line 4 are not parallel, we can also dismiss the possibility of coincidence. So since line 3 and line 4 are not parallel, would there be a chance that line 3 intersecting with line 4? To find out the answer whether line 3 is intersecting with line 4, we would need to equate the x coordinate, the y coordinate, and the z coordinate of L3 and L4. So equate the x coordinate means we are going to look at 1 plus t times 2 and also 1 plus lambda times negative 1. So let's put down that equation. 1 plus 2t equals to 1 minus lambda. Similarly, if we equate the y, you should get minus 1 minus t equal 0 plus lambda. And using these two equations, we can actually find what is t. We can substitute we can substitute lambda as minus 1 minus t into this equation. So 1 plus 2t equal 1 minus negative 1 negative t. 1 plus 2t equal 1 plus 1 plus t. And we can see that t is actually 1. With t equals to 1, we can find lambda, which is negative 1, negative 1, negative 2. So lambda is negative 2, t is 1. So what can we do with this lambda equals to 2 and t equals to 1? I think some students already know what to do. You can take note that we have not written the z coordinate. So the third equation now, when we try to equate the z coordinate, that is 4 plus 3t equals to 3 minus 2 lambda. If line 3 intersecting with line 4, when we substitute t equals to 1 and lambda equals to negative 2 into this equation, the equation will be valid, meaning left hand side equals to right hand side. So 4 plus 3 times 1, and right hand side is 3 minus 2 times negative 2. Left hand side you will get 7. Right hand side is also 7. That means when we substitute t equals to 1 and lambda equals to minus 2 into the z equation, the equation is true. If this is the case, meaning line 3 intersecting with line 4 at a common point. And that common point, you can either use lambda, put it back into line 4, you will get the point, or you can plug it in, t equals to 1, plug it in into line 3, you will get the same point as well. So let's try to plug in lambda equals to minus 2 into line 4. The coordinate is 3 minus 2 and 7. Therefore, our conclusion here is line 3 intersecting with line 4 at the point 3 minus 2 and 7.